Our next speaker is the soon-to-be doctor, Marc Young. He's in the middle of a PhD at Flinders University, and I've had a sneak peek of one of his theses on the Younger Dryas. It's 50,000 words. It's basically a book, and it was amazing. And he's also wins the award for the most miles traveled to be here today. He's from Australia. And he's basically a walking encyclopedia on the subject. So he's going to take us on a ride for an hour, talking through all of the up-to-date information that he's got to bring us. And then he's going to be joined by two very special guests. Dr. Joanne Ballard, who studied a PhD at the University of Tennessee, Knoxville, and a master's at the University of Cincinnati. She's a professional ash hunter, that's what I've nicknamed her. She's an ancient fire expert. She's been to multiple sites digging up all the earth and analyzing the ash particles and seeing if it points to the Younger Dryas Comet impact. And he's also going to be joined by Dr. Alan West, one of the co-founders of the Younger Dryas Comet Research Group, who I just have to point out are not running this event. This event is run by George, but they are very, very welcome guests and speakers. He's one of the original trailblazers of the Younger Dryas Comet theory, one of the top dudes in the field, and I cannot wait to hear of everything they've got to say. So I'm going to invite Marc Young to the stage.
Howdy, everyone. How's it going? That's the way. My name is Marc Young, and today I'm going to be talking to you about the Younger Dryas Impact Hypothesis. Where's that? Right, yeah, okay. So, my story starts around 2017, when I discovered the Younger Dryas Impact Hypothesis on the Joe Rogan podcast with Randall and Graham. And the notion that such a catastrophic event happened so recently and has gone largely unstudied inspired me to enroll at university to study the phenomena. So in 2018, I got in contact with George Howard of the Comet Research Group and began collaborating on the comprehensive Younger Dryas Impact Hypothesis bibliography, which catalogues every single scientific paper ever written about the Younger Dryas and allows anyone to access it at the click of a button. When I completed my double bachelor's in 2021, I was welcomed by George and Alan West of the Comet Research Group as a researcher. In 2022, I finally got the chance to work on the YDIH myself. I was determining the reasons for early issues with replicability with the magnetic micro-spherules, which is some of the evidence that I'll go through with you shortly. And the grades that I earned for my thesis were good enough to earn me a fully funded PhD in geoarchaeology. So... Okay. Right. So I'm sure most of the people here have heard of the Younger Dryas, but it's worth discussing exactly what it is. Oh, that's scrolling through my notes. Can you make it work on these slides, please? Right. Okay. So the Younger Dryas refers to a period spanning between 12,800 and 11,600 years ago. It was first discovered in the 1890s in a Danish peat bog, and is marked by a dramatic resurgence of a pond called the Dryas octopetala. The Younger Dryas was later corroborated using many different methods in fields including paleoceanography, glaciology, and archaeology, and today it's the most intensely studied climate oscillation in the last 2.5 million years of the Pleistocene. Widespread atmospheric changes took place in less than 1 year, as recorded in the ice cores and lake valves, and temperatures in central Greenland plunged by up to 15 degrees Fahrenheit in a very short time, within a few decades, and lasted for more than 1,000 years. Then at the termination of the Younger Dryas, temperatures skyrocketed by even more drastically within less than a decade, leading into the Holocene. Critics of the Younger Dryas Impact Hypothesis often claim that the Younger Dryas is nothing special, but nothing could be further from the truth. This is a temperature record of the last 85,000 years or so, and at first glance you might think the critics could be correct. I mean, just look at all these normal temperature oscillations, many appearing at first glance to be similar magnitude to the Younger Dryas, which is marked in red. These are called Dansgaard-Oeschger events, and they're marked by a large upward spike in temperature for a short time, followed by a major drop back to the former temperature. However, there's many reasons why the Younger Dryas is not comparable to these DO events. For one thing, fire frequency. Fire frequency steadily increased leading up to the Younger Dryas onset, and after the onset, frequency decreased. This is essentially the opposite pattern to all previous DO events, which experienced fewer fires leading up to their onset and more fires after. Perhaps one of the most anomalous features, however, is the atmospheric methane concentrations. In the top graph, produced by Greenland ice cores, it is clear that atmospheric methane tracks closely with the Greenland temperatures in the Northern Hemisphere. You can see it tracking pretty closely with the other DO events there. However, the bottom graph, produced from the Antarctic ice core, shows all these DO events were marked by much more muted methane signatures. However, at the YD, it mirrors it almost exactly, which suggests that whatever methane perturbation occurred was global rather than regional, like previous DO events. Now here's that methane perturbation at high resolution, but as we can see, there was also a major influx of radiocarbon into the atmosphere, which has long wreaked havoc on radiocarbon dates from around the YD boundary. In the radiocarbon calibration curve, this increase causes a 400-year anomaly within a space of about 100 calendar years. And this final graph shows a major increase in freshwater discharge into the oceans beginning at the Younger Dryas, closely correlating with cooling in both polar and tropical temperature reconstructions. Another interesting feature of the YD onset is that it occurred at the peak of the solar radiation cycle, which is governed by things like the precessional cycle, the variations in Earth's orbit, and the angle of Earth's rotational axis in relation to the Sun over hundreds of thousands of years. All previous DO events over the last 100,000 years or so have occurred when Earth was in a glacial period, which ended with the YD. You'll also notice that the methane anomaly, marked with the upper red arrow, is totally unique among the last 4 glacial interglacial transitions, which are marked in yellow here. Finally, and this is the most telling difference in my opinion, despite there having been many glacial to interglacial transitions and hundreds of individual DO oscillations, only the Younger Dryas marks a transition between the geologic and cultural timelines. The termination of the Younger Dryas marks a transition from the Pleistocene to the Holocene, and also the Paleolithic to the Neolithic. None of the others do. So now that you've seen several unique characteristics of the YD onset and how they differ from previous DO events, let's get on to the consequences. One major event that has captivated scientists for centuries, including Charles Darwin himself, is the mass extinction of the Rancho-Libraean, or the Ice Age megafauna. More than 50 genera of megafauna went extinct, either directly at or very close to the Younger Dryas onset. As you can see, the windows of last appearance of all megafaunal species in this graph overlap the YD onset. This means that statistically, all of these animals disappeared at the same time, all at the Younger Dryas onset. As these species were disappearing from the fossil record, there were major changes in vegetation dynamics occurring all over the world. This recent high-resolution study from the northwestern Europe shows that these changes occurred abruptly and simultaneously throughout northern Europe, precisely aligning with the Younger Dryas onset. These same vegetation changes occurred simultaneously throughout most of the world. Here we see very significant changes in the eastern United States, particularly concerning tree demographics. And as you can see, some of the records display larger changes in some species at some locations than at other periods. But overall, the largest dynamic changes in these records occurred at the Younger Dryas onset. We see similar things in southwest China, where dynamic changes at the YD onset and throughout the YD itself are some of the most significant in the entire record. Though it is clear that the effect of the YD on vegetation was less significant in these records than in other regions. This particular record is one of the most interesting, is from South Africa, deep in the southern hemisphere, where it's traditionally been believed that the Younger Dryas had little effect. On the contrary, we can see that major changes in vegetation dynamics occurred here, directly coinciding with the Whitey onset, as demonstrated by the temperature change. It seems pretty reasonable to expect that with the magnitude of these changes you've just seen, there would have been some significant effect on the human populations. Well, according to a small but vocal group of archaeologists who are long-standing critics of the Younger Dryas Impact Hypothesis, humans wouldn't have even noticed these changes. Apparently, they were just a bunch of ignorant cavemen who have no intimate connection to or understanding of the environment and how it changes. This is an example of the thinly veiled racism promoted by archaeological establishment in North America, which they so desperately project onto people like Graham Hancock. Of course, this is utterly moronic. Indigenous peoples have their finger on the pulse of nature, and they would have been keenly aware of the changes taking place around them. The Whitey onset manifests in the archaeological record throughout most of the United States as a transition from the Clovis lithic technology into later, fully fluted and differently styled forms. Additionally, throughout the southeast, many of the quarries used to procure the material they used were abandoned completely. Similar changes occurred throughout much of the world at the Younger Dryas onset, with the Magdalenian, Hamburg, and Federmesser cultures disappearing in Europe, and major cultural transitions throughout the Levant. In 2015, a group of 101 researchers modeled the ancient DNA genomes from more than 456 geographically diverse individuals. The study found that beginning around 10,000 years ago, a major chromosome bottleneck occurred, resulting from a ratio of 17 females for every one male. It's complex, but there are reasons why the timeline could be inaccurate, and I'll be detailing that in the thesis that Jana mentioned. Following the work of these authors, a brand new study from last year published the first genomic evidence of human populations inhabiting South America up to 21,000 years ago. An absolutely incredible discovery. In that paper, they discussed the Younger Dryas Impact Hypothesis as having potentially played a part in the disappearance of these people. So here's a few following quotes from the paper. In this work, it is proposed that the population foci that existed 19.3 thousand years ago in what is now Mexico, Peru, and Argentina, and Brazil, could have been drastically affected by the environmental episode that occurred during the Younger Dryas period. Q haplogroup Native American sublineages, older than 12,900 years ago, would have suffered a drastic decline at the YD period, altering the ancient spatial structure of the human populations of the Americas, and causing the extinction of lineages and loss of part of the gene pool. Despite this study making the rounds in the popular scientific press to some degree, this study has yet to be addressed by a single terminally online Twitter scientist, as I like to call them, John Hoops or Carl Fegans, for example. So what exactly is the Younger Dryas Impact Hypothesis? In 2007, a group of scientists led by Dr. Richard Firestone and Alan West held a press conference at the American Geophysical Union, announcing a suite of evidence that they claimed were indicative of a major cosmic impact over much of the Northern Hemisphere. Shortly after, the Firestone et al. Paper was published in the Proceedings of the National Academy of Sciences. Among the authors of the paper were many well-respected scientists in their fields. We have Professor Wendy Walbach. She's a leading expert on biomass burning from the KT Impact event. She did much of the work on the wildfires from that event back in the day when it was all kicking off. Professor James Kennett is a pioneering paleoceanographer who, alongside Wallace Broker, discovered the Younger Dryas in marine cores. Dr. Richard Firestone himself was the leader of the Lawrence National Berkeley Labs Isotopes Project, and he literally wrote the encyclopedia on radioactive isotopes. Dr. Ted Bunch is an astrogeochemist, formerly of NASA, where he was a section chief. He was an expert on impact materials, and his PhD was instrumental in establishing the diagnostic protocols for shot quartz. Unfortunately, he recently passed away, so rest in peace, Ted. As you can see, contrary to the claims of the Younger Dryas Impact Hypothesis skeptics, these guys aren't a bunch of randoms. They're very well respected within their relative fields. Their evidence can essentially be divided into two groups: geochemical impact proxies and the environmental consequences. Their geochemical evidence came in the form of a peak in magnetic grains and micro-spherules, increased concentrations of iridium and nickel, extraterrestrial metals, a radiation anomaly at some sites, and a distinct peak in charcoal and other carbon products like aciniform soot, which are like microscopic bunches of grapes. They're pretty cute. And they're all formed at very high temperatures. And then we have the carbon spherules and the glass-like carbon. They claim that the occurrence of these geochemical impact proxies in a very thin layer that was deposited in the aftermath of the megafaunal extinctions and vegetation changes and cultural upheavals. And this suggests a relationship between them all. They proposed several hypothetical scenarios for a YD event that could produce the evidence they were reporting. And this is one of the reasons why they faced such intense criticism from critics. They didn't have a clear idea of what they were seeing to start with, and you basically never do in science. Instead, their study was designed to say, here is all this evidence. We're not sure what happened, but we think these are some possibilities. And we think we have enough to justify a major investigation to find out what happened. A central component of the hypothesis was the Younger Dryas black mat. This several-inch thick, usually black layer, has been identified at more than 80 sites across North and South America and a few in Europe as well, and it marks the onset of the Younger Dryas. Contrary to common belief, the black component of the layer is not from charcoal or burning. Instead, it's from rotting vegetation, algae, and diatoms. If you picture a cold, damp wasteland in the aftermath of a major catastrophe, that's essentially what this black mat represents. The impact proxies the Firestone team found were present in a very thin layer directly below the black mat, not in indirect contact with it, but not within it. Importantly, no remains of the Rancho Librayan megafauna or the Clovis technologies are found above the mat, only below the mat or within it. This black mat layer essentially marks the boundary between two worlds, pre and post-catastrophe. The first line of geochemical evidence I'll be talking about is the magnetic micro-spherules, which I studied for my honours research. They're formed primarily by terrestrial sediment during an impact or airburst event as it gets sucked up into the plume by the convection. And molten droplets of silicate material cool or quench as they fly through the air, and they freeze into aerodynamic forms like spheres or teardrops. And vaporized iron actually condenses on the surface of these, which indicates, obviously, if you've got temperatures that are vaporizing iron, you're definitely dealing with something abnormal. In this example on the left, a molten ball of silicate material formed from quartz sands that were vaporized during the impact. And you can see the purple layer on the outside is the iron, and the blue on the inside is the silicate material. While they are referred to as micro-spherules, they're often not spherical at all. As I mentioned earlier, there's tear shapes, there's dumbbell shapes, there's completely random shapes, because the dynamics as they fly through the air, they're spinning and doing all sorts. So they take many forms. And the geochemistry of these spherules is somewhat unique among previous impact events. As we can see with the yellow and blue, they differ chemically to cosmic spherules, and they differ from anthropogenic and volcanic. And they're most chemically similar to impact and nuclear spherules. But they do cross over with surface sediments, obviously, because that's where they're derived from. So the magnetic microspherules found in YD sediments, particularly from ground zero sites, closely resemble the magnetic spherules produced by nuclear airbursts, both inside and out. The spherule shown in red on the left appears morphologically consistent with the one on the right in red. As you can see, they're spherical and there's little chunks of material coming off of them. And the geochemical map of the nuclear spherule in yellow is entirely consistent with the Younger Dryas magnetic spherules. An internal composition rich in silicates, coated by a thin layer of iron, derived either from the parent body or from natural oxides in the terrestrial sediment. Finally, the top row of objects on the left are examples of scoria-like objects, also referred to in the literature as melt glass. These objects are known to be diagnostic of a nearby impact and are produced from the same processes as their magnetic cousins. One of the most important archaeological sites ever discovered is the village of Abu Hureyra in Syria. It contains the earliest evidence of systematic agricultural practices such as pastoralism and domestication of crops. However, there is significant evidence that this site was destroyed by a cosmic impact event at the Younger Dryas onset. As you can see, we have all of the diagnostic proxies of the impact: spherules, nanodiamonds, melt glass, and carbon spherules. And here's an artist's impression of what people within the line of sight of Abu Hureyra would have witnessed as their village was destroyed 12,800 years ago. This site will be discussed later in depth by Andrew Moore, but in his 2020 paper on Abu Hureyra, he presented irrefutable evidence that this village was destroyed by a large airburst at the Younger Dryas. These are some examples of melt glass found at the Abu Hureyra in Syria, formed at more than 4,000 degrees Fahrenheit, which is enough to reduce a car to a pool of molten metal in less than a minute. The lush artillerite, shown in the right in the green there, is produced by the Libyan desert glass airburst event. And as you can see, it's almost morphologically identical to that on the right. One of the impact proxies that's not been thoroughly studied, as those we've just covered, is the carbon spherules. These rounded carbonaceous spheres are found in the Younger Dryas boundary layer, and they're proposed to have formed either during the impact event itself or the major wildfires that were triggered by it. So critics of the Younger Dryas Impact Hypothesis, they manufactured samples in order to test this theory, and they gathered all these different samples from different sites and they combined them. And then they looked through them to find the carbon spherules. And it's possible that they might not have even had the Younger Dryas layer in that sample. But the carbon spherules they found, they characterized as fungal sclerota or bug feces. Yep. But there is one property of these spherules that mean this simply cannot be true, which I'll discuss shortly. Another form of anomalous carbon is the glass-like carbon. This is essentially carbon from plants that's been melted at extraordinary temperatures and splattered around before cooling rapidly. The temperatures required for this to form are similar to the formation of the melt glass, far beyond any normal wildfire. Like the carbon spherules, these have a special property that means they are very unlikely to have been formed by any other process than an impact event. They contain trillions and trillions of nanodiamonds. Now ask yourselves, do bugs shit nanodiamonds? I don't think so. So these nanodiamonds have been very controversial. Using the same manufactured samples as the carbon spherules, critics have claimed these objects are not nanodiamonds at all. However, this group is only one out of half a dozen or so that have been unable to replicate the presence of nanodiamonds at the Younger Dryas boundary, and they're found only in the Younger Dryas boundary, not above or below. A 2014 review by Kinsey et al. Compiled all published data on nanodiamonds at the time as part of a comprehensive review on nanodiamonds. These graphs show the concentrations at the YD boundary from a wide variety of sites, spanning much of the Western Hemisphere. In all cases, again, none were found below or above, except maybe in Arlington Canyon there. So this study also explores the possibilities of how these nanodiamonds were formed and made some important clarifications that have mostly been ignored by critics who seek to debunk the YDIH. Early claims about nanodiamonds included that these diamonds were hexagonal Lonsdale-like and they were formed by shock produced by the impact. However, this has been shown not to be the case, and more likely they were formed by the chemical vapor deposition method, in which vaporized carbon is deposited on a surface in a diamond-like lattice. Obviously, you need very high temperatures for that. As you can probably imagine, yeah, that's more or less it on those. So following claims in the original Firestone paper, there were several attempts to disprove the notion that there was a major peak in biomass burning at the Younger Dryas. One particular study by Marlin et al. Cast considerable doubts on the notion of widespread biomass burning at the Younger Dryas onset. And this sent the Comet Research Group back to the drawing board. For the next 9 years, the Comet Research Group, led by Wendy Wolbach, spent their time examining and accumulating as many charcoal records as they could, resulting in a 2-part publication in the Journal of Geology. They applied the same methodology as Marlin et al. To a much larger dataset of more than 150 lake cores, ice cores, sediment cores, and marine cores. And their findings were astounding. They found that in between 30% of records, fire frequency was highest within the 400-year period of the Younger Dryas, 400-year window spanning the Younger Dryas onset, with a further 14% of records containing the second highest fire frequency. Furthermore, 66% of records spanning 4 continents contained at least one major biomass burning peak at the Younger Dryas. This image in the top left, it shows a charcoal record from a deep ocean core in the Pacific. And this is the clearest indicator I've ever seen that some sort of major fires were burning at the Younger Dryas. You can see the major spike at 50,000 years ago. I don't know what that is. Probably something big. But then, obviously, the second highest in the whole record occurred at the Younger Dryas onset. Wow. Some of the ice core evidence for the major biomass burning is also very compelling. Major biomass burning aerosols like ammonium, acetate, formate, and oxalate occur right at the Younger Dryas, and they're the largest in a 6,000-year window. And then the Greenland ice cores exhibit a major spike in ammonium, as discussed earlier. You may notice the ammonium spike occurs a little bit later in the end group core, and we don't know why that is, but it could simply be a case of misalignment of the data. Another indicator of cosmic impacts is elevated concentrations of platinum group elements. These elements are rare in the Earth's crust, so elevated concentrations are thought to be indicative of either cosmic impacts or volcanism. The dinosaur killing impact was first discovered when scientists detected a massive spike of iridium. And a slight iridium signature was also found at the Younger Dryas boundary by Firestone et al. While elevated iridium concentrations have been found at the Younger Dryas, iridium is not the major geochemical signature of the Younger Dryas impact event. That would be platinum. So in 2013, a major team of Harvard scientists, they published a massive platinum spike in the Proceedings of the National Academy of Sciences, and they discovered it in the DISC-2 ice core. Originally, they set out at the behest of Wally Broker to disprove the impact hypothesis by looking for platinum group elements in the ice core. And they ended up finding it there, and it is today one of the strongest lines of evidence ever found for the Younger Dryas impact. Later studies set to link the PT spike with volcanism, but the most comprehensive reconstruction, shown on the right, of volcanic events in both the northern and southern hemisphere, they used these events to synchronize the ice cores from both the north and the south. They definitively showed that the platinum occurred after any major volcanic event, so it wasn't related to volcanism. So it must have been some sort of cosmic impact. The first attempt to replicate this platinum anomaly at the Younger Dryas onset was conducted by the Comet Research Group, led by Chris Moore, at a host of archaeological sites throughout North America. And they found it at almost every site they examined, though to a varying degree. So some of these spikes are quite large, and there's only one of them, while other spikes are a bit smaller, and there's a couple of them. And the ones with multiple spikes are considered to have been caused by reworking of the soil. So older soil goes out and comes back in by erosion and such. So in 2019, the geographic extent of the platinum geochemical signature was extended into the southern hemisphere in both Africa and South America, essentially confirming the initial suspicion that the platinum was dispersed via the atmosphere. The addition of these sites makes it clear that the YD geochemical datum is truly global in nature. Today, the impact proxies have been found at the YD boundary in more than 100 sites on 5 continents, with many hypothesized local impact sites. At some sites, like Wonder Crater in South Africa, only the platinum anomaly has been found so far, but more work is ongoing. And much of Asia and Oceania has not been investigated yet. So now I want to quickly address some of the common misconceptions that people have about the YD impact. Contrary to the claims of some, the scientific evidence doesn't support the notion of a global flood. However, as you can see by this major spike of 6 feet or more in global sea levels, occurring right at the Younger Dryas onset indicated by that black arrow, there was clearly a catastrophic sea level rise event at the Younger Dryas onset. I mean, it's only 6 feet though. It's not like a world drowning flood or anything. And interestingly, in this record, meltwater pulse 1b shown in the yellow stripe, it only shows up in Barbados. And obviously that's not the case with the spike at the Younger Dryas. It shows up globally, so that's interesting in itself. Another misconception is that the whole world was on fire. Recent studies have shown, that Walbach paper, for example, that around 9% of Earth's terrestrial biomass was on fire at the Younger Dryas onset, within a period of 150 years. Rather than a whole continent being on fire at once, there would have been large areas or regions affected by small impact events, and it would have been like a patchwork. It wouldn't have been a whole continent burning, because there'd be a lot more damage. And finally, there are major misconceptions, particularly with critics, involving the size and type of impact scenario. The YD impact was not comparable to the impact of the KT boundary. It wasn't one big, one-and-done impact. Instead, it was much more likely a particularly violent meteor shower. It rained down on the world periodically over perhaps a couple of decades. And while it's different to previously established types of impact events, this violent meteor shower scenario is strongly supported by observational astronomy, and a vast body of literature proves its legitimacy. However, in 2018, a large impact crater was discovered beneath the Greenland ice sheet. Several of its characteristics made its discoverers think it was incredibly young. Simulations of the impact suggested it occurred into 1.5 to 2 kilometers of ice. The oldest ice in the crater dates to the Younger Dryas onset. Impact-scorched carbon from Pleistocene conifers was found in the impactites, and that they lived between 2.5 to 3 million years ago. And there's even indications of remnant geothermal heat emanating from below the crater. It's figuratively still smoking. And it's geomorphologically pristine. It has a nice central uplift, and there's minimal erosion around the crater rim. But it was recently dated to 58 million years ago. How can this be? Well, shortly after it was discovered, they found a slightly larger, much more eroded crater upstream from Hiawatha. Initially thought to date to a few 100,000 years ago. and Hiawatha was originally thought to date to around the Younger Dryas, so there's a bit of a difference there. Glaciers and ice sheets are known for bulldozing material and carrying it hundreds of kilometers. Did these 58 million years old grains, did they come from this crater? Is this crater much more ancient than Hiawatha? And did these grains flow into Hiawatha and drain out of the drainage channel to be sampled by scientists and dated to 58 million years ago? The only way to know for sure is to drill the crater, but it's currently under ice, so it's going to be quite expensive. And while the recurrent threat of meteor streams like the Taurids is a clear and present danger, they're far from the only threat to our planet from comets. Much similar comets can also undergo fragmentation events. Much smaller comets, disintegrating into tightly clustered cloud of debris that gradually spread outwards over time. This is essentially the same as what happened to form the Taurids, but because the original comet is much smaller, it doesn't form a massive meteor stream like this. This was formed by progenitor comet Encke, and Earth passes through this debris field twice a year, and it's equivalent to crossing a highway blindfolded. If you cross at 2 a.m., you're probably going to be okay, and you're not going to get hit by much at all. But if you cross at peak hour, school pickup time, you're probably going to have a bad time. The most famous airburst in recent history is the Tunguska event of 1908. A 50 to 60 meter comet fragment exploded about 10 kilometers in the atmosphere, and it projected between 5 and 15 megatons of energy to the ground, instantly flattening 2,000 square kilometers of forest. And these are thought to happen on a 200 to 500 year frequency. And I plotted the damage field of Tunguska over Asheville, and you can guarantee that we'd all pretty much be dead if it were to happen right now. But Tunguska is far from the only airburst event to have occurred in human history. In 1490, more than 10,000 people were killed in airbursts over Qiyang in China. Just 22 years after Tunguska, a chain of airbursts occurred over the Brazilian Amazon, with estimates of their size ranging from 1 megaton to 3 megatons. Within just a few years, there was no trace of these airbursts on the ground as the Amazon rainforest quickly reclaimed the damage. And then in 1976, a meteor detonated over Manchuria on the outskirts of Kirin City in China. It showered the ground below with more than 100 fragments, ranging in weight between 1 and 3,000 pounds. You wouldn't want to get hit by that one. The most destructive airburst since Tunguska occurred in 2013 over Chelyabinsk in Russia. It released 450 kilotons and resulted in 1,600 hospital visits and 12,000 broken windows. There's videos that were captured by security cameras and dash cameras, and anyone can watch them on YouTube and experience what it's like to witness an airburst on the very, very smallest end of the scale. And even just 5 years ago, an asteroid about half the size of Chelyabinsk detonated over Kamchatka in Russia. And this brings us to an observation made in 1883 by an astronomer named Jose Bonilla at the Zacatecas Observatory in Mexico. At the time, we had no understanding of cometary fragmentation events and meteor stream formation, and so Dr. Bonilla did not understand what he was seeing. However, he kept very good notes, and these notes were reinterpreted in 2011 by modern astronomers also at Zacatecas. And the results were astonishing. What Bonilla witnessed was a tightly clustered cloud of cometary debris passing very close to Earth. More than 3,300 fragments ranging in size from 50 meters to 1 kilometer passed within 5,000 miles of Earth, and perhaps as close as 300 miles from Earth. For reference, the Moon's distance from Earth is about 230,000 miles. a billion-ton swarm of cometary debris passed more than 50 times closer to the Earth than the Moon. Had Earth been just 5,000 miles closer to the Moon, we would have been struck by a civilization-ending Younger Dryas-like event just 140 years ago. The evidence at the Younger Dryas boundary points to at least 5 localized impact sites, and perhaps more. As a meteor enters the atmosphere at several thousand miles an hour, it can detonate before it reaches the ground, projecting a jet of superheated plasma and ejecta to the ground. The thermal pulse from the detonation is brighter and hotter than the surface of the sun for several seconds. Any witnesses will be blinded, and any sediments or buildings will be melted on a very thin layer on the surface. And then the shockwave follows, accompanied by tornado-force winds devastating everything in its path. Before most of the evidence I've just shown you had been published, the theory was prematurely rejected by the scientific community due to this treatment in the popular scientific press, as well as in the journals themselves. James Lawrence Powell is known for his systematic reviews of geoscience issues, and he conducted a thorough literature review of the Younger Dryas Impact Hypothesis based on the bibliography that I and George Howard have been working on since 2018. And he found that these papers made most... Okay, so he found that a few early papers published by critics in the years following the hypothesis, so he found that these papers made most scientists in the field take no more notice of this hypothesis. So these early negative conclusions, they basically turned everyone off of the theory, and no one kept any notice of it anymore. So importantly, it detailed how many of these early papers were underpinned by very poor science. Almost all of these early papers had major flaws in their methods, like earlier I mentioned about that cobbled together sample from all of these different sites. And then the early magnetic micro-spherules papers, very poor methods. I'm publishing a paper by the end of the year, hopefully, that goes into detail about why that early study failed to find any magnetic micro-spherules. So despite this premature rejection, the CRG and other independent groups continued presenting progressively stronger evidence. And today, the Younger Dryas Impact Hypothesis is enjoying a major resurgence of interest within the scientific community. Powell concurs with Dr. Martin Sweatman, who's also speaking here today. In his 2020 paper detailing the impact evidence, Dr. Sweatman concluded that rather than being referred to as the Younger Dryas Impact Hypothesis, it should probably be promoted to the level of being called a theory. And so Powell published a book called Deadly Voyager in 2020, and then a follow-up paper in the scientific journals in 2022, detailing the premature rejection. Today, a major focus of the Younger Dryas boundary research going forward is shocked quartz. It's long been established as the gold standard in diagnosing an impact event. Early in the hypothesis, shocked quartz grains were found at the Younger Dryas boundary, particularly in Europe and also in Mexico, I believe. But then the shocked quartz mafia shut it down. Gatekeepers like Christian Coble and Scott Harris claimed that because only one shocked quartz grain was found here, it more than likely made its way into the sediment from somewhere else, formed by another impact, apparently. They also claimed that contrary to crater-forming impact events, airbursts don't produce shocked quartz. They don't produce sufficient pressure to induce the shock metamorphic properties, I guess. However, the latest work of the Comet Research Group seeks to change this. We have confirmed the presence of shot quartz at multiple Younger Dryas boundary sites using a host of analytical techniques. And we have also found good candidates from additional sites that are awaiting confirmation. A recent publication in the journal Geosciences by the Comet Research Group has identified low-pressure shock metamorphic features in quartz grains from nuclear airbursts and compared them to known shot quartz from Meteor Crater in Arizona. And they found that they share distinct similarities in the types of features that we're seeing. This paper sets the stage to introduce this low-pressure shocked quartz from other Younger Dryas boundary sites, and from other airbursts like Tunguska, and from Tal El Hammam, which Dr. Collins is going to be talking about at some point over the weekend. This is some of the shot quartz found by the CRG at Tal. So on the left here, we have the original shot quartz that was found in Europe, and that's like very clearly shot quartz. There's no arguing that. But on the right over here, this is the recent study that shows the Joe and the Trinity detonations can also produce very similar planar deformation features. And this is some of the shot quartz that the Comet Research Group found at Tal El Hammam. And it clearly exhibits signs of low-pressure shock metamorphism. And that's it. So I think now we're going to be joined by Alan West and Joanne Ballard for an extended Q&A session. If anyone in the audience has questions, feel free to... we'll have a mic running around, and we'll have a team of Comet Research Group scientists ready to answer for you. And here's Johanna.
Oh, hi. I'll just fill. We're just waiting for Dr. Alan West to arrive.
Yeah, I think the shot quartz mafia might have taken Alan out, but where's
Oh!
Dr. Joanne Ballard?
Where's Joanne?
Is she
She's
coming around
coming.
the stage? Okay.
Ah, she's here. Amazing. Right, Q&A.
All right, do we have a roving mic?
We're a roaming mic, and I'm going to be roaming with it. Bear with me.
Mm-hmm.
So while we're waiting, I could talk for a
Yeah, go for it.
So, like Mark, in 2007, I was inspired by Rick Firestone's paper coming out and how interesting that was, and could I test that? So, I went to the University of Cincinnati, and they didn't have a way to check for platinum or iridium, and so I opted to look for charcoal. Would I find a big charcoal spike in lake sediments? So, Tom Lowell was my advisor. He's a glaciologist, and so you look at lake sediments because they're considered to be maybe a good repository of what's going on in the environment. You can look at pollen, charcoal, geochemistry, diatoms, all kinds of things. So I chose to look at charcoal, and I went to Michigan and cored several lakes, and so it was very interesting. So in addition to the predicted spike at the Younger Dryas in Swift Lake, there were other spikes. So as a charcoal researcher, you have to consider other things, you know, particularly if you have pine or spruce forests, which were in Michigan at that time in the late glacial and were later replaced by more predominantly oak, maple, other types of trees. So anyway, that's how I got my start in studying the Younger Dryas. I went on to the University of Tennessee and worked with palynologist Sally Horn to kind of put together a more comprehensive look at what else was there, and that's where I discovered that you can find a signature of wood ash in the lake sediments, and that is in the form of siliceous aggregates, and these are little tiny silica structures that are in the wood ash that dissolve and make a gel, because wood ash is very alkaline, and that percolates down through the ash and sticks to silt or whatever else is in there. And we found those siliceous aggregates at 5 of the 6 sites during the late glacial. So that's a suggestion there that maybe there's a catastrophic fire that occurred at that time. All right.
I think we have some questions.
We do, here in the audience.
Hi, David Clayton. I have a question. The research you're talking about, is that specific to proglacial lakes? Or is that just, I'm actually from the Saginaw Bay area in Michigan, and I'm very curious about like what lakes were sampled, and then are those, I guess, would these be categorized as the proglacial lakes?
No, they were not. They were kettle lakes, Slack and Swift Lakes, Big Fish, and Lake 16, and these are all in the Flint, Michigan area. And you can see the details of it if you go to the Trace, Tennessee. Just Google my name, Joanne Ballard, Lake Glacial. You'll probably be able to access freely my dissertation if you want to see my results in a graph.
It's also in the bibliography. You can just click a button and go right to it.
All right, thank you.
Mm-hmm.
Bibliography to be found at cosmictusk.com.
An awesome
Okay,
site.
and by the way, we did point out, you can probably see now, there are 2 mics right there and right there, and we'll be taking the questions from them. We'll go mic to mic, so if there's someone at both.
Hi. I
Thank you,
noticed
sir.
during your presentation, at least a couple times you referenced comparison to samples taken from nuclear weapons tests.
Yep.
So where is that data kept? Are there physical samples available for examination, and how do you get access to that?
I'm almost certain there would be samples available. Most of it's published in the scientific journals. I don't actually have links to this stuff in the bibliography, but that's something we can maybe work on, add an extra tab or something. But essentially, nuclear airbursts are the closest analog that we have to these airburst events, because we've only ever seen 1 or 2 that we've been able to study. So they've been simulated plenty of times, but yeah. So.
And one of the original authors on the 2007 paper and several subsequent papers was Robert Hermes of Sandia National Labs, or maybe it's Los Alamos, actually Los Alamos. And he's the expert in trinitite, which is the resulting glass from such explosions. And so they went to him and said, what does this glass look like that we find at this particular archaeological layer? To you, Robert, he said, well, that looks like what we find below the nuclear weapons tests, and I'm an expert in that. And he had quite a distinguished career too, and a lot to lose, but he knew what the data said, and he joined us to publish it.
Should we have a question from over there?
Question. All right, this is a question from Patrick, who's from the live stream, and he said, what caused the end of the Younger Dryas? Why did the temperatures rise after the 1,200 years?
Well, that's interesting. Not a lot of study has been done on impact proxies from that time, but there is some hint in some sites, like Hall's Cave. There's another large platinum spike that coincides with the end of the Younger Dryas. And I believe there was another site with something that would suggest that maybe an impact occurred then as well. But in this, at least regarding the scientific evidence, there's not a lot linking an impact to the end. But certainly something, I would say almost certainly happened at that time.
And it happened suddenly.
Yes.
Something extraordinary.
And it happened much more suddenly than the onset, actually, within less than 10 years.
So that's another mystery. And that was a good question.
And the climate stabilized like it hadn't been stable for hundreds of thousands of years before. We live in a sweet spot that isn't evident in the temperature records, which is kind of amazing, isn't it? You know, it's almost like we got a reprieve
We'll wait for these
to
questions
try to
roll
accomplish
through.
something.
And then,
That sounds unscientific, but you know, it's amazing how stable it's been when you look at that wild graph before the Younger Dryas. I just wanted to point out that a lot of these graphs, the scientists forget, are in intuitively reverse order. So when the right side is older, right, instead of the left side.
Yep.
Okay.
We'll have one from here.
Yes, I was just wondering, you were talking about the carbon glass and other odd carbon. How did the impact create the anaerobic effects? Because at 4,000 degrees, even nitrogen will combine with carbon.
So anaerobic being a lack of oxygen.
Oxygen and nitrogen.
Yeah. Well,
We did this.
I would assume that both the atmospheric effects of the air burst, they would starve it of oxygen, and obviously nitrogen as well. And you're right, any oxygen and nitrogen within that plume would be consumed. So if there was oxygen and nitrogen in there, because typically it pushes the atmosphere aside as it comes through. So there is like a vacuum there with no atmosphere. And so...
I know Dr. West actually has a patent with at least one other researcher where he believes that the nanodiamonds did not actually come from space, that they were formed as a part of the turbulent anoxic superheated
And they can
atmospheres
form
of
in
space.
activated charcoal
That's
industrially.
exactly right.
Under high nitrogen or high steam conditions and high temperature.
We've
But
actually
look,
reproduced it in the laboratory. We've made nanodiamonds from activated carbon. And someday somebody's going to pick that patent up and make a lot of diamonds.
we'll go over here.
Yeah, Mark, I actually made a note of one of the, well, you mentioned something, you used the analogy of a street crossing that we periodically pass through periods of activity. I was actually just going to ask you if you could elaborate on that just a little bit.
Yeah, sure. So as the parent body orbited in a resonant orbit between Jupiter and the Sun, it began to disintegrate. And at different stages, there was different levels of disintegration. So naturally, throughout this torrent of objects, there's going to be patches that are more dense and patches that are quite light on objects. And so when Earth passes through a particularly dense section of this, that's when we sweep it all up and it comes raining down. But most of the time, we're passing through quite a sparse section. So, yeah, I hope that helps.
I've heard Alan refer to it as long periods of quiescence interrupted by sudden and horrific trauma.
We'll go over here.
Yeah, I would like a prompt you for more information on regarding the massive platinum spike, which you briefly put that it lasted 14 years.
Yep.
In relation to the black mat deposit. So you said it was kind of cold and wet, and that layer was kind of algae based. So if you elaborate on how long this deposit, the atmosphere was cloudy, and its causation of the black mat. Thank you.
So the black mat overlies the impact layer that contains the platinum. So there might be a tiny little bit of platinum in the very, very bottom of the black mat, but the black mat was formed over 1,200 years as opposed to 14. So, yeah.
A lot of the material lies directly beneath the black mat.
Yeah.
And when they go and test the faces of archaeological sites, along the strata, they test below the black mat. That's where they get the hits.
Yeah.
Right? And incidentally, Mr. Chris James, who's a great friend of these subjects from the Netherlands, who flew all the way from there to here and also went on our Turkey trip recently, he obtained some black mat just last week from the Oslo layer in the Netherlands, and it actually covers all of northern Europe, but it's just as distinct as it can possibly be, just a dark line right through. And I've got some of this, and you can play with it. There are probably millions, or if not trillions, of nanodiamonds within this.
So I have studied sites in the Oslo horizon at 5 different geographically distinct locations, and I have found melt glass there, fused quartz, charcoal, fresh wood that's glazed with melted silica. So that's a pretty impressive site that dates to, there's some variation, of course, because of the problem with dating things at the Younger Dryas onset, but it's generally thought to be a distinct boundary. It's a black mat in the Netherlands called the Oslo Horizon, first studied by Bas van Hale in 1989. He wrote a paper on it. But there's also the Finno soil in, I think it's Germany, and there's also a black mat type layer in Poland. So pretty interesting sites over there.
Just like the U.S., if it's in a grading environment and hasn't eroded away, you're very likely to have some of the material still in there. And honest to goodness, it could be in your backyard.
And that location over there, that's all the cover sands. So that burn layer is in the cover sands, and it's very distinctive. And you often find sponge spicules in it. So that also points to damp conditions that the sponges have to grow in a shallow substrate.
It was a wasteland.
I would agree with that.
Yep. We'll go over here.
Hi, Mark. Just to help paint a picture, I'm curious if an airburst can create the shock quartz or if it's only an impact, and do the data suggest that what we might be looking at is some kind of combination based on whatever the constituents of the Younger Dryas impact objects were, whether it's lower density, higher density, or a mixture? Are you seeing that there were probably some airbursts and some actual impacts that form craters?
I'd say almost certainly. So in the type of scenario that we observed in the vanilla observation, there was large chunks and smaller chunks, and you would think in a YDB-like scenario that there would be large airbursts, smaller airbursts, and potentially even impacts. And the Hiawatha crater could be the main part of the body, and its fragments rained over everywhere else. So it's not either or regarding the Hiawatha and the meteor shower scenario. And it's important to note that the Hiawatha crater dating to the Younger Dryas has no consequence over the actual greater theory. So whether it does or does not date to that time, it doesn't really matter.
But there's also many other small craters that haven't been particularly dated to the Younger Dryas. That's the Bloody Creek structure over on the east side of Canada, as well as the Carousel structure.
And there was one in Louisiana as well. What's that one? The Saint something parish?
I'm not
and the Roseau structure in Michigan as well, I think.
Yeah, I'm trying to remember the name, but recall that you know, at that time, the Earth is always 70% water, right? And you had the northern latitudes largely covered with ice.
A
So-
2-mile thick ice sheet, the Laurentide ice sheet.
That's right. So you're working with 20%, 15% of what terrestrial Earth today was available to that. So what would that be then? 85% of the world was water and ice, and you wouldn't see a typical impact structure anymore.
Yep. We'll go over here. Oh, over here. Yep.
Hi. I was just looking at the biomass slide you had, and I live in one of the most beautiful parts of the country, I think, but it's in the middle of that biomass burn area. And I'm wondering if that is why we have so much uranium and platinum in Colorado and eastern Utah, was from that biomass.
Are we talking
burn.
about deep deposits of these elements?
Yeah.
Or? Yeah, I wouldn't think so.
Okay.
They probably would have been formed in deep geologic time, and we're talking very recent times here, so yeah.
Okay, thank you.
No worries. And we'll go over here.
Yes, I'm wondering if there's any speculation on the difference of the crater at Hiawatha versus the one at Behringer, and how preserved Hiawatha is. With Behringer, obviously not seeing any ice or rain for thousands of years.
Yeah. So Behringer crater is about 50,000 years old, which interestingly correlates with that massive charcoal spike in that ocean core we saw. Not saying anything about that, but maybe.
Maybe.
And so it's obviously very pristine. It's only had wind and water erosion acting on it. And I'd say Hiawatha is probably a bit more degraded than that because it's had trillions of tons of ice bulldozing it for maybe a few thousand years. If it happened at the Younger Dryas, a few thousand years. But the thing is, if it was 58 million years ago, there wasn't even any ice on Greenland at that time, and you've had every single glacial cycle throughout the Pleistocene bulldozing it constantly, and you're not going to have a pristine crater like that if it was formed that long ago.
I'd add that the Chesapeake Bay crater, not really far from us, right, is 35 million years old. And we didn't discover it till the early 1990s because it's so obscured and so difficult to detect. And there wasn't any ice there. Well, there probably has been the last 35 million years, perhaps, maybe. But just think about it. So it's half as old and is completely obscured. and had to be found with modern deep drilling techniques. And then there is something that is another 20 million years old, purportedly, and it's in absolutely pristine condition.
And isn't the
I
ice?
smell a skunk.
Isn't the ice above it? Didn't they say that there's about 11,000,
That's right.
13,000?
The oldest ice in the crater dates to the Younger Dryas onset. So
Every hint the original researchers gave suggested that they absolutely were internally convinced it was Younger Dryas. And what I heard, on the down low, who knows whether it's true, is that they struck 27 mentions of the Younger Dryas out of the paper, the reviewers did, out of the original science paper, and just had them strip that part out. And they could only refer kind of elliptically and cryptically to it being 13,000 years and possibly coinciding with the climate change. They couldn't say it explicitly.
Science sometimes doesn't like controversy. They don't like catastrophes, as we know from J. Harlan Brett's and the Channel Scablands situation. Geologists at that time said everything has to happen slowly. They didn't like him introducing this idea of we had a catastrophe out there, and that's kind of persisted, I think.
Exactly, Joanne. These are great questions, by the way.
we'll go over here.
I have a two-part question. The first part is, how much of this shows up in the Greenland ice core? In all those samples, do you get all the ash, do you get all the burning? And the other part has to do with, from the seascape of all the debris you see on the maps you showed earlier today, would there have been an airburst over the Atlantic Ocean that would have that would have done two things: raised the temperature and put a lot of moisture up into the air, and that would have helped create that long cooling period?
Yeah, I'd say regarding the first question, you would expect to find ejecta or ash in the ice core alongside the platinum, and that's one of the reasons, well, obviously we don't, and that's one of the reasons why people are so skeptical of it.
But you find ammonium and
Yes.
other markers of
Biomass burning
wildfires.
proxies, but not ash itself. And in the Walbach paper, the biomass burning paper, they suggested that the amount of wildfires at that time would have introduced enough soot to the atmosphere that it would have blocked out the sun for perhaps 1 or 2 weeks, causing an impact winter. And you probably would expect to see some form of ash that's made its way through the atmosphere and landed in Greenland, but we don't see it there, which is interesting. It could be an issue with resolution. So the ice core data record is quite coarse in most of them. The JISP2 is pretty high res, I think.
But ash is mostly calcium carbonate,
Yeah.
which is a confounding thing because calcium carbonate is in limestone and in solution, calcite in lakes and whatnot. So it could be dust. Calcium can be dust. And so the calcium ion in the ice cores, who knows if that could be related to ash.
And regarding the second part of the question, an Atlantic Ocean impact, in the violent meteor burst scenario, you would definitely expect there to be some over the ocean. As George said, 70% of the world is ocean or something like that. So the majority of impacts and airbursts would have occurred into the ocean. The amount of water introduced into the atmosphere, that's an unknown, at least as far as I'm concerned. You would expect there to be some.
I think it'd be more interesting to think about an impact to the Laurentide ice sheet and what's the dynamics of that.
Yeah,
But it could be the ocean as well.
yeah. So yeah, I'd say it's likely, but we don't see any sort of signal of that. And perhaps that's because we haven't been looking, but perhaps it didn't happen, so yeah.
Thank you very much.
No worries. We'll go over here.
Hey, Mark, great presentation. Thanks for being here.
Thank you.
Making it all worth it. Great research. So you discussed as when this impact happened, it raised the ocean about 6 feet.
Yeah, so at the Younger Dryas onset, the sea levels rose about 6 feet very, very quickly, yeah.
So a lot of people attribute the Younger Dryas to the Göbekli Tepe, to the Sahara Desert turning into a desert, a lot of other things like that. But do you believe that are you in that same realm of thinking that this could have had tidal influence across the world? Because you seem to dismiss, I don't want to say you dismissed, but this is not the great flood from Noah. This is something else.
Yeah, so originally the idea was that a major release of meltwater went into the ocean at the Younger Dryas and caused a freshwater lens on top, which prevented heat from the oceans reaching the atmosphere, and that's what was responsible for the cooling. And that's not mutually exclusive with the impact scenario. Like, the impact could have released that meltwater in the first place, and there's reasons to think that. But yeah, I don't see there being too much of a environmental impact other than obviously 6 feet of shoreline being erased. I'm not sure if that properly answers your question. I kind of forgot part of it, but...
You've been up here a while, Mark.
I have.
And we've still got a little ways to go.
Yep. We'll go over here.
Hi, thank you.
No worries.
I'm a little short. I'm 70 years old, and I feel like I'm home for the first time. And by the way, I love pajama researcher. I'd have worn my PJs if I'd have known earlier.
I don't think it insulted anybody. We know what we're talking about.
I kind of am anyway. My question is a little different. I was looking at timelines of history and doing that kind of research and some diaries from ancestry and that kind of thing. And the catastrophe of 536, it's totally missing from the timeline. How many people have to be complicit in removing truth? I have a 1965 yearbook that talks about a woman that was running from a catastrophe. Where is it?
Yeah.
I've got 16 timelines and nothing.
Yeah.
Stay close to the mic.
This is the part that undoes me. I'm not afraid to die. I am afraid of people that refuse truth.
God bless you. That's wonderful. And we're going to nail it long before you're gone, okay?
So there has been a bit of work done into the 536 AD, was it, event. There is a radiocarbon anomaly at that time, which has been found in tree rings. And it's most of the research that's been done has focused on volcanism as a cause, because I think there's ethnographic or historical documents that state that the sky was dark for a prolonged period during that time. So it could have been a volcanic event, it could have been an impact event, it could have been just a major fire that blocked out the sun for a while. But it does seem to have manifested throughout most of the northern hemisphere in the tree rings, but...
With a frost ring, I think.
Yeah, yeah.
But isn't there sulfate? I don't know if that's the one that has the sulfate in the ice cores.
Yeah, there's a few in a short period. There's like 774 and then 1260 or whatever. So there's some would say it's a somewhat cyclical event, and it could be related to another meteor stream or something like that, but unfortunately there's not a lot of hard evidence like there is for the Younger Dryas. Obviously smaller events will leave less evidence, so I definitely sympathize with the idea that it's being covered up, but I don't know that that's exactly what's happening.
Well, it's all mixed up with a mess of volcanic explosions,
yes,
right? Which in themselves, a sweep of volcanic explosions around the world during a certain period is kind of an odd phenomenon in itself.
Yeah.
Who knows? Could it be related? But Michael Bailey, who's an Irish tree ring researcher, first defined the 536 event because he saw that the California Bristol cones, the taiga trees in northern Russia, the Irish bog oaks, all those trees stopped growing at the same time worldwide. He also found 4 other instances worldwide, separated by 1,500 years, 2,000 years, since the Younger Dryas, where every tree on Earth stopped growing for a significant period. Somebody's got to explain that. Could well be volcanoes. but there are things to suggest that it could be related to civilization collapse in antiquity and before.
And as you're going to see throughout the weekend, there has been a lot of other historical airbursts that have occurred. And any one of those or any others yet to be identified could have been responsible for those events. So,
exactly.
Yep. So we'll go over here.
Yes. Hi, Mark. I'm 69, as long as people are mentioning their age.
Nice.
Yeah, thank you. My question regards your discussion there about that airburst that occurred in China in the 1400s.
Yep.
How were they able to get a head count of the dead and vaporized? Is that a guesstimate?
Well, they probably weren't counting the vaporized people. But
that's why I'm saying maybe
yeah.
it was a falsely low.
Yeah, I mean, obviously you have some idea of who would be missing, so you could draw a conclusion from that. But I think the Ming Dynasty records that record this, they go into a little bit of detail about the recoveries and how the event played out. It describes it as a rain of meteors. People were actually crushed by meteors more than they were destroyed by the airburst. At least that's how it's written. Obviously, they didn't understand how airbursts worked back then, and they may have attributed, they may have called it a falling meteor without knowing what the explosion was. But yeah, I can't really answer that. No.
Yeah.
Yeah.
Worth a shot.
It's very interesting, though.
You could take a look at that reference, too, and see what
Yeah,
what
that's
he
what I
says.
was
Yao
gonna
et al., was it?
Yeah, Yao et al.
1994?
Yeah, and interestingly, it's also on Wikipedia that this event happened. It's in the list of most catastrophic events under, I think, airburst or asteroid impact or something. So, yeah, there's a bit about it out there.
Okay, thank you
and
very
obviously,
much.
you can look into the original Ming Dynasty records and
We'll drop a link on the Telegram thread, too.
Yeah.
If you speak Chinese.
Yes. Yeah, well.
It may have been translated.
I'm sure there'd be
Okay.
translations.
ChatGPT
There you go.
Yeah. I will go over here.
Thank you.
My question is still along the line of the airburst of like, now that we've had so many that we know for sure are airbursts, have we done any kind of research in those specific areas to see what kind of particulates or phenomenons have occurred in those areas that would maybe agree with what's in the black mat?
Yeah, so not necessarily with what's in the black mat, but following the Tunguska airburst, they actually identified unique carbon forms that had rained out of the atmosphere from the airburst. And that might be a diagnostic tool we can use down the track once we establish that they get preserved, obviously. But in terms of modern airbursts and what we see in the black mat, we haven't experienced anything close to the level of what happened at the Younger Dryas in modern times. So I think our closest analog would be Tunguska, and there is some proxies from Tunguska that we see in the Younger Dryas. We've got the micro-spherules. I think we found
nanodiamonds,
shock
I believe.
Yeah, nanodiamonds, shock quartz. Yep. So in short, yes, but it's not well put together yet. So
okay, thank you.
Yeah, no.
You're looking at a significant number of the researchers looking into the evidence for these events, which is, and what I want to add too, I think Johanna touched on it. Both of these folks got their seeking and received their doctorates deliberately focusing on the Younger Dryas impact. That's what interested them. And they're not a handful of those in the world, and we need more of them, right? And any young researcher that wants to go seek a higher degree on these subjects is welcome to come to the Cosmic Summit at any point in their career, because they've got the right attitude and they've probably got some data. So.
There has been a few master's and PhD theses on the Younger Dryas by critics of it, because obviously their professors are the critics themselves, so they enlist their graduate students to produce the data that goes against the hypothesis, and oftentimes...
So winning strategy.
At least in the case of one of them, it was clearly peer pressure from their researchers, and in the end they actually came out publishing a paper supporting the Younger Dryas Impact Hypothesis. So they published 3 or 4 negative ones while doing their PhD, and they came out later publishing a supporting one, so yeah. Yep. Yeah.
There's a good example of that same dynamic tomorrow with Chandra Wickramasinghe's discussion with me that I'll pull.
Yeah. We'll go over here.
Hey, thank you all for your efforts and your dedication to this. I want to touch back on the Laurentide ice sheet option and reference Antonio Zamora. He's done a lot of work in replicating the Carolina Bays. And I wonder if any of you have studied into that and if the ejecta curtain from an impact like that and the dynamics launching parts to the East Coast, the Atlantic Ocean, would represent a source for the algae, the sponges, and the diatoms spread over the land.
Yes, that is an interesting connection that you've made there. Obviously, there would be a lot of water being introduced to the land in the form of ice, and it would melt after a short time. Obviously, George is the granddaddy of the Carolina Bays.
And Chris Cottrell has a talk about that later.
So later in the conference, we're going to hear from Chris. And initially, I was really on board with the idea that they could have occurred at the Younger Dryas, but there's pretty strong negative evidence now, I would say, that they happened a bit earlier, maybe 780,000 years ago. There's been a large tektite field over most of Oceania and Southeast Asia called the Australite tektites about 780,000 years ago. And I won't get too much into it because Chris will get angry with me, but yeah, there's pretty good correlatory evidence that suggests that it actually happened back then rather than at the Younger Dryas.
But as far as the Laurentide ice sheet goes, I think that's a very interesting question. And there are a lot of kettle lakes in Wisconsin, Michigan, peripheral to where the Laurentide ice sheet was. And so I have hypothesized that, if you had an impact to the ice sheet, would there have been ice shatter? Would it have been all meltwater? If it was ice shatter, could that have been like ice ejecta that pinned some mammoths and mastodons, because farmers are, every now and then they'll discover a carcass of a woolly mammoth or a mastodon or something else on their property. And if you radiocarbon date that, one thing that you could do to test that hypothesis would be, do they have green bone breaks? And I may
stick fractures and
green,
stuff.
right. And so I have been told by a paleontologist there is some support for that hypothesis, but I will have to test that further or do it more systematically and get with a paleopathologist such as Bruce Rothschild. So, but that's a good question about, and the sponges, those were in Europe, but who knows if there was something like that here. But once the land dried out, unlike the cover sands that they had there where the black mat was buried, here, if it's a terrestrial environment, it's dynamic, and wind and water and earthworms and crawdads and everything will rototill and, disturb your pristine layers of what happened when. So.
If I may, further with the Laurentide ice sheet, it seems the Niagara escarpment dates at the same time frame, Niagara Falls.
It dates to around 12,000 when it has cut back, I think, over a period of 12,000 years. So that's an interesting question. And I don't...
There's radial cuestas as well through that whole space.
It's my belief that Niagara Falls is, you're looking at a catastrophic remnant that's still as amazing as it was the day after the event, but it's just about 15, 20 miles back. Because it eroded itself. And they used to think, I believe they thought it was much, much older. Yep. And it has gotten closer and closer into now where it dates, just as you've noted, right at the time period, which you see again and again
This sounds
and again.
like a good research project for him.
It sure does.
There's plenty more. Thank you all.
No worries, we'll go over here.
Hi. Thanks very much for that talk. I wanted to talk about one of the misconceptions that you called out, which was the sea level rise.
Sure.
It was definitely a misconception that I had and kind of goes against, I guess, some of the things that Graham Hancock's been talking about and, the historical stories of Noah and the Sumerian epic of Gilgamesh. So I just wanted to, find out, is there other periods of time where there was, a significant sea level rise that might account for some of the stuff that they've called out, or is that just a complete misconception?
So it is important to remember, we're talking about what's published in scientific journals here, so there's obviously some sort of bias against publishing a global flood, but Graham Hancock's thesis about the sea level rise, it still applies because eventually they did rise and they did obscure all that land where the people would have been living earlier. So while it didn't happen instantaneously, like some people say or believe, it certainly was catastrophic. And there's all sorts of dynamics involved in sea level rise and fall and isostatic depression and all that stuff. So regarding the biblical flood and the Epic of Gilgamesh, they describe a global flood, but to claim that it actually was a global flood assumes that they had access to all of the world. To them, a global flood would have been all of their world flooding. And this happened repeatedly throughout the deglacial process, as Randall's going to talk about, I'm sure. There's sweeping megafloods came through the lands and filled up basins for quite an extended period of time. So it's quite possible that those oral traditions are referring to these type of events rather than a true global flood. And obviously, as I mentioned earlier, eventually it did flood, but it was much slower over several thousand years rather than all at once. But the result is the same. The landscapes of the past are drowned, and we have no way of really accessing them. So I wouldn't be too disheartened by the fact that there wasn't a global cataclysmic flood, but there certainly was major catastrophic flooding events around that time. We'll go over here.
Hey, I'm Tom. About 2017, I happened to catch an episode of Joe Rogan. It just happened to have Graham Hancock and Randall Carlson, and here I am 8 years later asking questions at the Cosmic Summit. Looking at the scablands, a lot of people look at the Channel scablands as evidence, and it's been geologically confirmed that there was a mega flood out there. But if you look at the southwestern, probably third of British Columbia, South America, areas around the Caspian Sea, central North Africa, the Sahel, northeast China, these features are all over the world. Are there any other studies? I've only found one for the southern third of South America.
Good pajama research, though.
Yeah. But I mean,
that's
are there
exactly
any,
what you do. You're looking for the studies, man. That's the kind of people in this room.
Are there any other ongoing research into all these other areas that are going to connect them or possibly connect them or disqualify them from the Younger Dryas event?
I know in Poland there's a pretty dedicated group of scientists over there that have been mapping the mega flood landscapes, and obviously you would expect that most of that research gets published in Polish language. So in short, there likely is a lot of literature out there, we just don't have access to it in English, particularly Russian studies. They don't, it's very obscure what happens over there. We don't really get much of it translated into English. So, and there is a vast body of research on the Mongolian megafloods that I witnessed the landscapes of myself in 2019. They're absolutely incredible. You mentioned South America. I know I talked to you earlier in the weekend about that, and I'm not aware of any sort of literature around there.
The Comet Research Group, who is it that just has done some work in Venezuela and Patagonia?
Dr. Bill Mahaney.
Bill Mahaney.
Yep. Those are interesting papers. And that was independent confirmation, too. He was not on the original paper. He popped up a couple years down around 2010 and said, oh my gosh, I've been studying this and wondering about this, Matt, and how to properly interpret it. And he just hadn't put it under a transmission electron microscope yet. Yeah.
Yep. So in short, there likely is a lot of literature, we just don't have access to it. But if there's not, then there should be. Because
George's comment about ChatGPT for researching with
translations, yeah.
Oh, I think it's going to revolutionize pajama research.
Yeah.
You'll be able to go, say, find the papers or any other kind of research, but we need more help than most of the academics do because they have so many more resources. But you know, AI is obviously going to be able to go dig up everything you need and summarize it for you, which is what we all try to do who aren't technicians. You go and read these papers, and I always tell people, don't get put off by the fact that you don't understand 70% of what the hell they're saying, right? You know, that 30% is valuable to you, and you're learning that 30%. And next time you read a paper like that, you're going to understand 35% because you looked up 2 or 3 terms, you know? So it progresses slowly, and, you know, you get your cred ultimately.
We'll go over here.
Excellent presentation, Mark. Thanks for coming all the way from Australia to present to us. Interestingly, if you go back in time, it appears that roughly every 12,800, 13,000 years, something is happening. The Younger Dryas obviously being the big one.
Every half precessional cycle.
Yes. And it involves tremendous heat, obviously, so it's something probably coming from out in space. Has there been any thought into the idea of it being sun-related, potentially our sun micronovaing or some kind of a massive CME type event causing some of the stuff we're seeing?
Yeah, so there is a lot of buzz about that. Obviously, Robert Schoch is a big proponent of that. And there are a few papers published in the literature that go in that direction. Even the original, when the original evidence for the Younger Dryas was discovered in 2001, or in the 90s actually, by William Topping, he took it to Richard Firestone and he said, what is this? And Richard Firestone, being a nuclear chemist, he approached it like a nuclear chemist. And he was quite convinced that it was from a solar storm. But then he was joined by other members of the Comet Research Group, like Alan and stuff, and they went back and they re-examined the evidence, and they found that it more likely represented a cosmic impact. So, I mean, the door's certainly not closed on the role of the sun in these type of events, and it could be a perfect cosmic storm where even like an impact into the sun, passing Earth, we'd catch a little bit of it, and then the ejection from the sun hitting Earth, like, there's any sort of number of combinations you can come up with for that kind of thing.
And personally, from a personal threat level, I find solar outbursts to be much more scary within our lifetimes, children's lifetimes, great-grandchildren's lifetimes, because within a couple of lifetimes back, it would have taken us all down. They happen every couple of 100 years, and they only seem to get more frequent in the record. And we know that we can't withstand that because we live on a thin veneer of technology that would be fried instantly.
And they affect a much larger area than a localized airburst.
And actually, there was a great book written on it by Newt Gingrich, and probably the guy that actually wrote the book. But Newt's pretty smart. I bet he did a good edit job. But it's called 1 Second After, and it's set in Black Mountain, North Carolina, right down the road. So all of the action, like they're trying to secure the reservoir here, they're refugees coming up from Charlotte, you know, bedraggled in their suits and stuff, and their motorcycle gangs, all around here as a result of an airburst. As a result of an outburst, a solar outburst. And that's just a horrific scenario, and that could happen, and that personally does concern me. Whenever the lights blink at the house, I'm like, oh my gosh. Yeah.
We'll go over here.
Hi, Mark. That was a great presentation.
Thank you.
I am an earth and space science teacher from Detroit, and I've, over the last few years, have been kind of implementing some lessons that get the kids interested in this stuff, and they are very much interested in it. I can say that, especially inner Detroit city youth, which you wouldn't think would be interested in it, but they're very interested in extinction events of megafauna and things like that. So being from Michigan, I have to ask, has there been more investigation into the Saginaw Bay being a possible impact crater site? And to follow that up, if you have the ice sheets that are melted and melted rapidly, and you have a stabilization of climate, would that not be a change in the albedo of the planet, which would help then stabilize the climate? So thank you.
Yep. So there's definitely those sort of feedback mechanisms involved in the deglacial process. Regarding the Carolina Bays, was it? Saginaw Bay, yes. Yeah, Saginaw Bay. So there are people who point to Saginaw Bay as the origin for the Carolina Bays impact. And if that was the case...
Including the Carolina Bays themselves pointing to.
Yes, yeah, exactly. They all align basically to it.
People, yeah.
So there's not a lot of scientific evidence from the actual region. There's no shocked quartz or anything that I'm aware of. And that's the sort of stuff you would need to justify that sort of event. But who knows, if it happened into the ice sheet, we don't really have an understanding of what that would look like in the record. So, and it could be all the way down at the bottom. I know that region's like very, very deep. So,
and there's salt up there in Michigan.
yeah, yeah. But regardless, you will hear about Saginaw Bay from Chris Cottrell, I assume, at some point throughout the weekend. And what was the second?
I don't remember. But Chris will do a great job at addressing that.
Yeah. So albedo, it definitely would have an effect, but the level of effect is what we don't understand yet.
Because clouds also have a albedo.
Yes, yes.
So
and any sort of water vapor released into the atmosphere from either melting the ice or impacts into the oceans would affect, they'd introduce clouds, and I assume it would cause some sort of cooling effect because...
This has been a great series of questions. I'm going to give it about another 3 minutes so we can add just a little bit to the intermission.
I think we've got a question from the live stream here.
We do, yes. Asking for a friend here from Brandon. He said, if I started digging in my backyard, how many feet down would I have to go to reach the black mat layer?
He wants it to be as shallow as possible. Yeah.
It really depends. There's areas where it's several meters deep. There's areas where it's basically outcropping on the surface. And there's areas where it's been eroded completely, so it's possible that he could dig as deep as he wants and he'd never find it. So it really depends where he is. And to complicate matters, there's plenty of other black mats out there. These aren't unique. There's things called paleosols, which are formed by human occupation, that are dark layers of soil, and they're not impact related at all. They're not catastrophe related. And you can dig through a whole section and see like 12 or 13 black layers. So it's really not that possible to determine whether you're dealing with the black mat unless you've got some radiocarbon dates from it that point it to about that time. Yeah. I definitely want to dig in my backyard as well and find the black mat, but I don't think that's going to happen. We've got one over here.
Yes, hey, my name's Richard Howard.
Nice to meet you.
That's no coincidence.
Be my brother.
Yeah. I have a question for Micah, the Australian native. The Australopithecus, did they get wiped out during their event, or did they make it across the landmass? And if they did, what did they turn into? And their cranial capacity was very small when they originally found the skulls and everything and measured the interior capacity. I think it was 22 cc.
Yeah, something like that. It's very small.
Yeah, if they survived, would that? And another question is, does the increase of the cc increase your intelligence? I mean, if you know, that's more for anthropology, but
yeah. So
I'm just wondering what happened to the Australopithecus.
Yeah. So
because it's a cool name.
It is. It definitely is. So the
Nothing else.
Australopithecus lived about 2.5 million years ago or so. So they're not quite related to the Younger Dryas. But having said that, the Pleistocene transition 2.5 million years ago, there's no data on this, but they certainly could have been wiped out by some sort of catastrophe. There's no way of knowing really, because that's a long time ago. But and regarding the intelligence linked to brain capacity, there's a recent series of papers out of a new hominin that they discovered called Homo naledi, and they also have very small cranial capacity, but they've been found to have been using fire. So they're about 250 to 300,000 years ago, and they were using fire. They were intentionally burying their dead, and they were making geometric symbols on the wall. So that all suggests some sort of intelligence, human-like intelligence, with a very small brain capacity. So, in short, it's typically been thought that smaller brains are dumber, but we're finding out that that's not really the case. So,
We got time for one
Thank
more.
you.
Yep.
Thank you, Richard.
Over here.
I wanted to make a mention that the flood myths probably are reoccurring from the 70% of the Earth being water and multiple impacts. And just
Tsunamis.
5,000 years ago, the Burkle Crater in the Indian Ocean more or less wiped out civilization on the entire Indian Ocean surrounds.
Yep.
So it keeps occurring. So I'm all for planetary defense.
Yeah, definitely.
Thank you.
Thank you.
Okay.
Thank you all.
All right, thanks.
That's wonderful questions. That's some of the best questions.
Amazing.